Assalamu alaikum everyone. This is Tanvir Ahmed. My registration number is 2017-53. My first slide is all about the question, and the question is: suppose there is preferences are represented by u x1 x2 equal to x1 x2. The consumer pays p1 for price x1 and p2 for price x2. The question is: formulate information set for the utility maximization problem UMP and the expenditure minimization problem EMP. The second question is: calculate our Russian demand function and derive indirect utility function from them. And the third question is: calculate Hicksian demand function and derive expenditure function from them. My second slide is all about the first question answer. The utility maximization problem UMP is maximization of utility of x1 and x2 equal to x1 and x2. X1 and x2 are real number and subject to price of x1 equal to x1 and price of x2 means p2 plus p2 into x2 summation all p1 x1 and plus p2 x2 equal to y. And the second slide is the expenditure minimization problem, which is EMP, which is the minimum of price of x1 means p1 x1 and price of x2 means p2 x2. The summation of this and x1 x2 and real number and subject to utility of x1 x2 equal to x1 x2. And my next slide is about Marshallian demand function and indirect utility function. We said the Lagrangian form of the UMP, which is Lagrangian function x1 x2 plus lambda y minus p1 x1 plus p2 x2, which is first equation, and second equation is derivation of the Lagrangian equation. The first derivation with respect to x1, which is del L by del x1 equal to x2 p1 minus p1 lambda equal to 0. This is the second equation, and third equation is the derivation of x2 with respect to x2, and which is x1 minus p2 lambda equal to 0. And the third derivation is with respect to lambda, which is value is y minus p1 x1 minus p2 x2 equal to 0. And this is the fourth equation. Here is some note about the derivation after the derivation. So I had the solving for the x1 x2 gives the Marshallian and demand function, which is xm1 py equal to y by 2p1 and xm2 py equal to y by 2p2, which is derived from the I just try to derivation, the further derivation was for your convenience, that is the note here, the from equation 2 and 2 to 4. By equation 2 we get the value of x2, which is p1 lambda, and by equation 3 we get the value of x1, which is x1 equal to p2 lambda. And by equation 4, we get y equal to p1 x1 plus p2 x2. And by this equation, we get lambda's value, which is x2 by p1, and also we get the lambda another value, which is x1 by p2. And if we substitute this lambda's this value x1 and x2 value in y equation and y equation, then we get y equal to p1 p2 lambda and p1 plus p1 p2 lambda. And after that, if we substitute the value of the lambdas in this equation, we get y equal to p1 p2 by x1 by p2 and p1 p2 p2 x1 by p2. Here's the mistake is typing mistake is lambda, which is not included. After this, if we calculate this value, the p2 is cut, and then we get y equal to p1 x1 and p1 x1. and then we get y equal to 2 y equal to 2p1 x1 and x1 equal to y by 2p1. By this equation we get the xm1 value, and after in the same procedures if we get then we get the x2 value, and which is the y by 2p2. So this is an easy equation. If we get sometime, we can easily solve out this. After that, we can form the indirect utility function by substituting the Marshall and demand function back into the direct utility function, which is the into of this two equation. And after the into, we get the y by 2p1 into y by 2p1, and we get y square by 4p1 p2, which is the value of bpy. This is the finish of the second question. After this, we go to the third question, which we get the Hicksian demand function and indirect utility function. We get Lagrangian function of EMS, then Lagrangian function P1 x1 P2 plus P2 x2 plus mu u minus x1 x2. In the second slide, we get the setting partial derive of the Lagrangian equation to 0. The same procedures of the previous question we get, which is the Lagrangian function, then a derivation of with respect to x1, we get p1 minus mu x2, which is the value is equal to 0. And again we derive the equation by x2, and we get p2 minus mu x1, and this value also 0. Again we get a derivation by lambda with respect to lambda, then we get u minus x1 x2 with this value also 0. If we calculate this value with some number of equation, then we get this value. Solving the for equation x1 and x2 give the Hicksian demand function. Hicksian demand function x is 1 du equal to whole root over up2 by p1. And if you don't understand this equation, how can we calculate this? I just some note here. What their note is, if we calculate the other function, like first function, second equation, then we get some p1 value and p2 values, and we get u values. And after this, we can easily find out the mu's value, which is p2 by x1. And if we try the p1 by mu x2, and yeah, I get easily get the x2 value, which is x2 equal to p1 by mu, and we also get x1 value, which is p2 by mu. And after that, we substitute this value in u equation, u equal to x1 x2. So we substitute x1 value, x1 is p1 by mu, and x2 is p2 by mu. So I get easily get u by p1, and further derivation, we easily get this equation x1 mu equal to u p2 by p1 whole root. And in the same procedures, you can easily find out the x2 value. So that's not a big deal. I hope you can understand this. And after this, we can form the x20 function by substituting the Hicksian demand function back into the objective function of the EMS. So we get the value by the previous question procedures, just into of this x1 and x2 whose value, and we get the up1 up2 by p1 p2 whole root, which is value of the bpy equal to x s1 pu into x s2 pu. PU equal to and then we get the easily substitute this value, and then we easily find out this. So I hope you all understand this math. I hope I think this is not a big deal. You can understand easily. So thank you for the watching this video. Assalamu alaikum.
ভাইয়া এখনো সেন্ড